In this class, I will explain some problems on the computation of fluid pressure. So in the earlier video classes, I have explained about the definitions of fluid pressure, how it is expressed as pressure intensity and pressure head, and hydrostatic law P is equal to gamma into H, Pascal's law, and classification of that is pressure, absolute pressure and gauge pressure, vacuum pressure and all. So now the problems related to fluid pressure can be in different ways. So first problem, convert a pressure of 750 kilopascals into pressure head of water. So here he has given the pressure in the form of intensity. So this is kilopascal means kilonewton per meter square. So when the pressure is given in kilonewton per meter square or newton per meter square or pascal, it is called as intensity of pressure, pressure intensity. That we have to convert into pressure head. So pressure head is expressed in meters. So pressure can be expressed either in intensity form, newton per meter square form, or it can be expressed in terms of head, that is in meters. So let us see here how it can be converted. So here 750 kilopascal means 750 into 10 power 3 newton per meter square. So this is the pressure value, it is the intensity value. Now we know that gamma of water is 9810 newton per meter cube. So we have this hydrostatic pressure law, P is equal to gamma W into HW, where W stands for water. If it is some other liquid, we have to express in terms of that liquid. Now here P is given as 750 kilopascal. So gamma W you know, therefore we can find out HW. So HW, it is the pressure head in terms of water. So P by gamma W, P is 750 into 10 power 3. Please note that this should be in newton per meter square and this will be in newton per meter cube, 9810. So if you simplify, you are going to get in meters of water. So this is the pressure head. So pressure head in terms of water. So pressure intensity can be converted to pressure head using this formula. Very simple exercise. Suppose if they give pressure head, that is in meters of water, you can convert that into newton per meter square by using the same formula, P is equal to gamma W into HW. So that is one problem. So the second problem, convert the above pressure in terms of pressure head of mercury. See here I have given the value in terms of pressure head of water. Suppose if the same pressure has to be converted into pressure head of some other liquid, here mercury is given. So specific value of mercury, even if it is not given, you can take it as 13.6. So here the thing is, same value of pressure, so you know in terms of water, that should be converted to in terms of mercury now. So the thing is, we know that P is equal to gamma H, so it can be gamma W or it can be gamma Hg and HHd, that is mercury. Now here, you know this relation, you know the value of gamma W, you know the value of HW, HW is this value, this should be converted in terms of pressure head of mercury means HHd is unknown here. So therefore HHd according to this equation, it is P divided by gamma Hg. Okay, so HHg is equal to P divided by gamma Hg. So P is here 750 into 10 power 3, that is known, divided by, now here this is important, gamma Hg. If you want specific weight of mercury, that can be obtained by multiplying specific gravity of mercury with specific weight of water. So this I have told you in the beginning class. So if you want the specific weight of any liquid, you can get that by multiplying the specific gravity of that liquid by the specific weight of water, because specific gravity is defined as specific gravity of the fluid divided by specific gravity of water. Now that is how we have to write here. So this gamma Hg is nothing but here SHg into gamma W. So substitute the value of SHg as specific gravity of mercury is given as 13.6. Gamma W is 9810. So if you multiply and if you divide this by this, you are going to get 5.62 meters of mercury. So that means the same pressure which is written as 76.45 meters of water, it is the same as 5.62 meters of mercury. So both represent the same value of pressure. In another way, you can find out this by just multiplying this value. Suppose you have the specific pressure head in terms of water you have. So that if you want to convert into pressure head of mercury, just divide this 76.45 by 13.6. So you are going to get same value 5.62. So this is how you can do in another way. So if you want the specific, if you want the pressure head in terms of mercury, divide whatever meters of water is there. By this specific gravity of mercury, you are going to get specific, that is, you are going to get the pressure head in terms of mercury. So like this also you can do. So this is how we can convert pressure of one liquid in terms of pressure of another liquid. Now the third problem looks like this. Suppose if the atmospheric pressure, P atmospheric, is given as 760 millimeters of mercury. Normally atmospheric pressure is expressed in centimeters or millimeters of mercury in the case of a barometer. So barometer is used to note the atmospheric pressure. So convert a pressure of 3 meters of water into absolute pressure. See the problem here. He has given a pressure of 3 meters of water. So actually this is absolute, this is the gauge pressure. So whatever he has given, this 3 meters is the gauge pressure. That means it is measured with respect to atmospheric pressure. So 3 meters of what is the gauge pressure, 760 mm of mercury is the atmospheric pressure. So you want to have the value in terms of absolute pressure. Yesterday I had explained in the earlier lecture that the relationship between the absolute pressure and gauge pressure. So absolute pressure and gauge pressure is nothing but gauge, because this is the relationship. Absolute pressure is equal to atmospheric pressure plus gauge pressure. If gauge pressure is positive. If it is negative, then it becomes vacuum pressure, so then it becomes minus 1. Now here, he has given this P atmospheric in terms of mercury. The gauge pressure is given in terms of water. So this is very important. So if they are given in different with respect to different liquids, you have to convert them into a single liquid, same liquid. Then you have to add. Otherwise, it will be wrong. So if you are adding atmospheric pressure and gauge pressure, they should be in same units, and also they should be with respect to same liquid. So that is the thing. So here now what I will do is, this mercury I am going to convert in terms of water. So because this is given in terms of water, 3 meters of water is the gauge pressure, I want to convert this atmospheric pressure also in terms of meters of water. So let us see how it can be converted. So 760 mm of mercury is the atmospheric pressure, that is 0.76 meters of mercury. Now, if you want in terms of water, you have to multiply by 13.6. So, if you multiply this value by 13.6, you are going to get the atmospheric pressure in terms of water. It comes out to be 10.336 meters of water. Please note that here, so whatever, so this 0.76 meters is there of mercury. If you are using 0.76 meters of mercury as the pressure column, the same pressure is exerted if you are using water by having a pressure column of 10.336 meters. So you will be having a higher value here. That is why mercury is used in manometers or barometers to measure the pressure and pressure difference, because you can read a larger pressure by using a smaller depth of deflection of mercury. That is the meaning. So multiply by 13.6 to get the value in terms of meters of water. So here, this is reverse here. You can see in the earlier problem, I have divided by 13.6 because this is from water to mercury. So conversion from water to mercury, you have to divide by 13.6. Conversion from mercury to water, you have to multiply by 13.6. This is very important. Now, once you get this also in terms of meters of water, then you can add. So, absolute pressure is atmospheric pressure plus gauge pressure. Atmospheric pressure is 10.336 meters of water plus gauge pressure is given as 3 meters of water. If you add them, you are going to get 13.336 meters of water as the absolute pressure. So, 3 meters of water is gauge pressure, 13.336 meters of water is the absolute pressure. Now, this actually this is nothing in terms of pressure head. So, it is in meters of water. Now, this can be converted to pressure intensity. So, if you want in terms of pressure intensity, so then you have to use this formula, gamma W HW. So gamma W HW gives the value of PW. So gamma W is 9,810. HW is 13.336, whatever is there here. So you are going to get 1,30,826.16 Newton per meter square, or this is in pascals actually. When you divide this by 1000, you are going to get kilopascal. That is 130.826 kilopascals. So this is the same. All these are same, but expressed in different units. That we should be careful. So this gauge pressure of this observed pressure of this gauge pressure of water is either you can write it as 130.826 kilopascal, or you can write it as 10.36 meters of water. So one will be in Newton per meter square or pascal, another will be in meters. So this is how you have to do the problem. You should be very, very careful in the conversion. So whether you have to multiply or divide by the specific gravity value, that you should be knowing. Next problem, you see here, there is a container here. In that container, you have a liquid of specific mass, that is rho value he has given. Rho value, mass density value in kg per meter is 1570. And he has given the atmospheric pressure. Atmospheric pressure will be acting at the free surface, that I have told. Here the atmospheric pressure will be acting, its value is 750 millimeters of mercury. What he has asked is, what is the gauge pressure and absolute pressure at a point A, which is at a depth of 3 meters from the free surface. Actually, this is the free surface. So depth is measured from the free surface. So what is the absolute pressure and gauge pressure at the point A, which is 3 meters below the free surface? That is the question, and that value we need in kilopascals. So that is what he has asked me in kilonewton per meter square. Now here, what we have to do is first we will find out the gauge pressure. Then we will add atmospheric pressure to the gauge pressure to get the absolute pressure. But only thing is, you should be very careful. They should be in same units. They should be expressed in terms of same liquid. Now here, see, this is in terms of mercury, whereas this is in terms of some liquid. This is not water. Please note that this is not water. If rho is 1570, its specific gravity will be 1.57. When this 1570 is divided by 1000, that is the specific weight of water, that is a specific mass of water, then you are going to get the specific gravity of that particular liquid. So it is heavier than water. So because for water rho is 1000, for this liquid he has given rho as 1570. That ratio 1570 divided by 1000 gives the value of S of that. So S is given by 1.57. Okay, now here let us see, first we will find out the gauge pressure at the point A. So gauge pressure if you want, so here he has given rho L. Rho L means this specific mass of that liquid, 1570 kg per meter cube. You can always find out gamma of that liquid from that. So rho into G is gamma, that you know from the definition. So rho into G. So rho is this, G is 9.81. So you are going to get the value in Newton per meter cube. So gamma is expressed in Newton per meter cube, rho is expressed in kg per meter cube. So once you get the value of gamma, now you can find out the gauge pressure. The gauge pressure means it is the pressure measured with respect to atmospheric pressure as data. So gamma into L gives the value of P. So whatever you are writing gamma into H, gamma into H is nothing but gauge pressure. Please remember that. So Pi is equal to gamma L HL. So gamma L is this value. HL is this height of water. Height of that liquid, whatever is there up to the free surface, that is 3 meters he has given. So when you multiply these two, you are going to get the value in Newton per meter square, 46,205.1 pascal. So Newton per meter square is nothing but pascal. If you can convert this into kilopascal, divide by 1000, that becomes 46.2051 kilopascal. This is the gauge pressure value at the point A. So it is expressed in kilopascal, as of in kilopascal. Now, if you want the absolute pressure at the same point, you have to add the value of atmospheric pressure to this gauge pressure to get the absolute pressure. Now, see here, atmospheric pressure is given in terms of mercury. So you should be very, very careful. So that should be converted in terms of that liquid. Here liquid is not water, it is some other liquid. So we have, when you are adding the two pressure values, atmospheric pressure value and gauge pressure value, they should be in same units, and also they should be with respect to the same liquid. Now this mercury I have to convert the value to liquid. So he has given atmospheric pressure as 750 millimeters of mercury, which is 0.75 meter. Let me convert convert into meters first. Then you should be very careful about this step now. So you have this relation. So gamma L HL is equal to gamma Hg into HHg. So liquid, here it is not water. So now if you want HL will be gamma Hg into HHg divided by gamma L. So here this formula we have to use here, because now it is in terms of mercury, that should be converted to a liquid. Mercury should be converted to liquid. So this is the formula we have to use. So gamma Hg is this. Now how to get gamma Hg? This gamma Hg is SHg into gamma W. SHg into gamma W. That is specific. Here I have written here. Same formula we are using here. So SHg into gamma W. So SHg value is 13.6. Specific value of mercury is 13.6 into specific weight of water is 9,810. So if you multiply these two, you are going to get gamma Hg. So please keep it in mind. Into this value, HHG is this value. So 0.75 divided by gamma L, gamma of that liquid, you have got it as 15,401.7 that you have to substitute. So if you simplify this, you will get 6.497 meters of that liquid. So now mercury value is pressure value is converted to liquid pressure value. This is very, very important step. Now this once again it is in meters, but this should be converted to kilopascal. Very important. One more step is there. So this is from mercury to liquid. Liquid meters. Now liquid kilopascal. So liquid kilopascal means P is equal to gamma H. So this is H now. For that liquid, this is H. That should be multiplied by gamma of that liquid. So like this. So gamma L into HL gives the value of the pressure in terms of pascals. Then you can convert into kilopascal. So this is gamma of liquid, this is H of liquid. When you multiply, you are going to get this much in pascals divided by 1000. This is the kilopascal, 100.0648. Now you got the value of atmospheric pressure in terms of kilopascal of the liquid, and you have the gauge pressure also in terms of kilopascal of the liquid. If you add these two, 100.0648 plus 46.02051, that gives the absolute pressure at A. So you are going to get the final answer as 146.2699 kilopascal. So very, very important, because definitely some confusions will arise. So there are two things here. One is conversion of pressure from one liquid to another liquid. So this stage, mercury to liquid, both are in meters only. Next, conversion of pressure from meters to Newton per meter square or Pascal. So that is this step. This step. So this is in meters, this is in pascals. So these two steps are very, very important. From one liquid to another liquid. Next, from meters to pascals. So this is how we have to understand the conversion of pressure from one liquid to another liquid, and also from meters to Newton per meter square.